Welcome to this tutorial on spatial data processing. Today we're going to walk through a complete workflow for analyzing Verona, Italy using Beast and Spark. We'll cover everything from downloading datasets to performing advanced spatial and Raptor joins. First, let's get our data set. Head over to UCR star and search for Verona, Italy. Find the OSM 21 buildings dataset and download the visible area in GeoJSON format. After that, visit Veneto Data Portal website and look for the administrative region entry and download the original shapefile, which will arrive as a zip file. If your Mac extracts it automatically, that's fine. For our raster data, we'll use the ESA World Cover dataset. Navigate to the dataset website and open the World Cover viewer. Zoom into Verona, select World Cover version 2, and download the product. It's about 135 megabytes. Just a heads up, you will need to be logged into your account to start the download. Now let's set up our Spark project. Search for UCR Beast Bitbucket and scroll down to the development setup section. Copy the generation command and paste it into your terminal. You can customize the artifact ID to name your project directory. For this example, we'll use test-spatial-data. Next, open IntelliJ, click Open, and select your new project folder. To complete the setup, create new run configuration and set the main class to Beast Scala. You can use Java as well if you prefer. To keep things organized, move all your downloaded data, the regions, buildings, and the world cover geotiff into your project's current working directory. We will start with a simple code that opens the building's dataset and plots it as an image. If you see an error of the file beast.xml not existing, try to resync the Maven project and run again. Now you will likely see another error mentioning storage util. This is a known issue in Spark with Java version 9 and above. Simply go to your pom.xml file, copy the configuration section provided there, and paste it into the VM options of your run configuration. Once that's done, your environment is ready. Now that the program runs correctly, you can see the plotted image. Now, let's do the same with the regions file, this time loading it as a shapefile. You might not be able to see the image if you use the dark theme, but you can open it in the system image viewer instead. Next, we will use spatial join to combine the two datasets and count the number of buildings for each region in Verona. You will initially notice that the result is empty. The reason is that the two datasets are in different coordinate references systems. There are two ways to explore this issue. You can print a summary of each dataset and the CRS associated with each. You will notice that the building dataset has bounds in the latitude/longitude space of Verona, and the CRS lists the World Geodetic System and EPSG 4326. Scrolling down to the regions dataset, you see the range is different and that it uses a different CRS. To fix this, use the reproject operation to project the region's dataset into the building's CRS. Now you can perform a spatial join. By using count by key, you can print a map showing exactly how many buildings are in each administrative region of Verona. Finally, let's look at land cover. Load your geotiff using the geotiff method. An easy way to inspect the data is to compute a histogram of all pixel values using the flatten operation followed by count by value. These values represent specific land types. For example, 10 is tree cover, 20 is shrubland, and 30 is grassland. And to get a more detailed view, we'll perform a Raptor join. This joins the raster data with our vector regions. Because we already reprojected our regions, the CRS will match perfectly. By mapping the join results to pair each region with its pixel values, and then calling count by key, you'll generate a breakdown of land cover types for every single region. And that's it. You've successfully integrated vector and raster data to analyze the landscape of Verona. You now have the tools to perform complex spatial queries and generate detailed land use reports using Beast and Spark. Happy coding!